Namaste, this is Aditya and welcome to Shankam Architect channel. In this video, I am going to talk about the architecture of AEM as cloud service. From very basic concepts to most complex concepts, I am going to cover many topics in this video. So the video might be a bit lengthier. I hope you'll be able to stay with me till the end of this video. If you are liking my videos, please share, like and subscribe. Let's get started with the presentation. Okay, so before starting the AEM cloud architecture, let's first quickly review the deployment architecture of the traditional systems. Okay, if you are not aware of this deployment architecture of the traditional systems, then I have already done a video, in-depth video on this. I'll leave the link in the description, you can check it out. But here I'm going to give just an overview. So here we have the author instance, and from author the content will be published to the publish instance. And then finally this content which is published will get cached in the dispatcher layer. And what are the CDNs? The CDNs are the content delivery networks, like they are the servers placed all over the world, and they will cache all the static assets like CSS and JavaScript at nearby to the client location. Server might be in some location, but client might be located in some other location which are like thousands of miles apart, but CDN will be placed at the nearest location of the client, wherever he is all over the world. At every nearest location for the client there will be a server, and from that server the content will be delivered. So this is the traditional deployment architecture which we have. Okay, so if we just go into the production environments, so the architecture could look something like this, right? We may not have one publish instead, and instead we will have multiple publish instances. So there might be one author instance, and from one author instance, when you publish the content, it might be replicated onto like 4 publish instances, right? And for those 4 publish instances, you might have one dispatcher running. And this dispatcher may act also as a load balancer for these publish instances, right? And again, it could do the caching, and caching could happen in the CDN also. So this is the traditional deployment architecture in the production environments which we generally see, right? But this deployment architecture has few drawbacks. Let's see what are those drawbacks now. So the problems with this traditional deployment architecture is that it requires high infrastructure cost. Like for example, if you see here, you have 4 publish instances, but there might be some instances like festival seasons wherein the load will be heavy on the servers, right? And there will be some low time where there will not be much traffic onto the website, and you may not be needing this all the 4 instances, right? So you might be just needing 2 instances. Maybe half of the year you might be needing only 2 instances, and only like the peak season might be for 3 months wherein you need all the 4 instances, right? So but when we are doing the traditional deployment architectures, we always need to consider the peak load time, right? And based on that, we'll have to arrive upon the infrastructure that needs to be built, because it has to sustain the peak load, right? So that is the whole point. So in that case, we can clearly see that there is a resource wastage here, right? All the time we may not need all the 4 instances. So that is what we are saying here. Like the infrastructure cost will be high. Like though we don't need some of the servers for almost 8 months, we have to still maintain, we have to still purchase those servers and also maintain it, which is a significant cost. Okay, and then comes the scalability. Like for example, we have assessed that our peak load these 4 instances can manage, but we had the additional load, and what if these 4 instances are unable to manage, and if we have to add one more publish instance to serve that traffic, that peak traffic, right? Then it is not so easily scalable. Again, we have to go for purchasing the new server, set it up, and then so much of process is involved in setting up the new instance, right? So that is what we are saying here, that there are scalability limits. It's not easily scalable. And then there are operational overheads. Like for example, you will have to manage your own AEM applications, right? For any of the upgrades. Like if there is any AEM upgrade, then it is not auto upgrade. You will have to you will have to put some developers and they will have to upgrade, and then all the code has to be refactored, and so many things are involved, right? So these are all the operational overheads if we have to manage the entire instance ourselves. And then other cases, the disaster recovery. Like for example, we have the 4 published instances. So this is the main instance, but we might have to maintain the recovery instance also. For example, one main instance might be placed in like Kashmir, for example, and other same setup have to be made in the Kanyakumari also, so that if there is any disaster in one area, you will have the data replicated on another area, so your data is not entirely lost, right? So in that case, the same infrastructure you will have to replicate in another instance, which will be again the huge cost, right? All the 4, so you will have total in 2 author instances and 8 published instances. So all this is again a lot of cost is involved, right? So these are all the drawbacks with the traditional deployments. So all these things are addressed and solved in the cloud deployments. Like for example, the cloud deployments are scalable, which means that when you have the low load, you will have only 2 published instances, and whenever there is a load getting increased, automatically the new published instances get created, so you need not worry about it. So it is auto scalable, so you will not have to incur the high costs upfront, and it is scalable, right? And in the cloud, what happens is Adobe manages all the upgrades, and they will run the test cases and everything, and they will make sure that your application is running fine even on the upgraded system. Okay, so they manage all the upgrades, which is good, right? So then disaster recovery also in the cloud environments Adobe will manage. So there is lot of management which Adobe is doing in the cloud environments, which will reduce the cost incurred by the client significantly, who is using the AEM for their websites. So what are the principles on which AEM cloud is built? Okay, so the first principle is always on service, which means that though they are doing upgrades, I told like upgrades are managed by the AEM, right? So though they are doing upgrades and other maintenance, they will make sure that our application is not going down, which is a very nice feature, right? So if we have to do upgrade ourselves, then we might have to take the downtime and we'll have to do some maintenance, right? But here in the cloud instance, you will not have to bring down the service at all. Okay, so it is always on. And then the AEM cloud is built upon the cloud native architecture. So the entire application is built on the cloud native architecture. So what is this cloud native architecture? This cloud native architecture enables us to do automatic scaling. Okay, so I told you, right, when there is a low load, we'll have to have only 2 published instances. But when the load increases, automatically one published instance has to come automatically, right? So how will that happen? So that will happen if you are building the architecture in such a way that you are making it cloud native. Okay, so then the automated scaling happens. Okay, so then you will also have the enhanced security. So Adobe puts a good security team, and they manage the infrastructure security and network security, so that the clients need not manage. But in the traditional deployments, client had to worry about all the security, right? But in the cloud deployments, Adobe will have to take care of that. So it is a big relief to the client who is using the AEM. So now let's see, like we told the cloud native architecture, right? So to enable the automatic scaling, the AEM has to be built on a cloud native architecture. So that's what we told, right? But what is this cloud native architecture? Okay, let's see that. So these are the principles behind the cloud native architecture. So first one is that microservices architecture. So you cannot have a single monolith application, which means to say that your entire application cannot be hosted just on the one server. It should be able to, your application, you should be able to divide it into the multiple parts, and you should be able to host it as a services. Instead of hosting the entire application as one application, you should be able to break it up into multiple services, and each service should be able to interact. Like this is service 1, this is service 2, this is service 3. Each service should be able to interact among each other and do a big applications job. And that services should be packaged as part of the containers. So what is this containers? What is this dynamic orchestration? We will see it later. Okay. So then coming to the DevOps practices. So what are these DevOps practices? So you should be able to push your code into the Git, and automatically all the code checks happens. For example, all the JUnit test cases will be run, right? And there will be security check happening, and there will be some Sonar or something which is running to check Java coding standards, right? So all these have to be run, and automatically the code build has to be deployed into the Adobe AEM instances, and automatically without any downtime the new code has to be deployed and it has to run. Okay, so these are the basic principles, if implemented, will enable a cloud native architecture. Okay, so what is the cloud native architecture? If you want to deploy any application into the cloud, you have to minimum maintain that it is following all these principles. Then it is called as a cloud native architecture. So till now we have just seen the terms, but to understand these things, right, you need to first understand what are data servers and how they look like. So this is how a typical data server center looks like. So if you are able to see the image in the background, you are seeing the huge racks, right? These racks, and here to them some huge racks. So this entire thing is called as a data center, and each of them, right, will be one server. Okay, maybe this server has a certain CPU capacity, this server has another CPU capacity. So in data center, what happens is we will have CPUs and we will have the storage separated. Okay, they need not be together as we see in our desktop, right? In the desktop we have the hard disk, CPU and everything fitted onto one system, right? But in the data center it may not be like that. You will have the set of processors like this, and you might have here some set of the hard disks, right? So like that. But a data center contains both. Okay, so it has multiple servers, which is the CPU units, and you will have the hard disks also. And these CPU units can interact with the hard disk. They can get the data and do all the persisted data things. Okay, so that's how this data center is built. Okay, so once you understand this data center concept, right, the another concept which we need to understand is orchestration. So what do we mean by this orchestration? Okay, we told earlier that we have two published instance, let's say, and when the load is increasing, it automatically has to install another published instance, right? So let's say this is our published instance which is running, and this is another published instance which is running. Okay, so now how do you know that load has increased? Someone should need monitoring it, right? Someone has to look what is the load on this server and what is the load on this server, and they have to recognize that the load has been increased, and they have to identify that a new server has to be installed, and you will have to identify the processing unit for that, and you will have to install AEM unit, and you will have to make sure it is up and running. So who is doing all that job? Okay, so all that job is being done by the orchestrator. Okay, so let's say this is our entire data center. This first track may be the processing unit in which our orchestration services are running. So this orchestration service will be monitoring all the processors for their load. Okay, and they will monitor and see for which processor the load has been increased, right? So all that is done by this orchestration service. So there are some set of processors or CPU units which are reserved for the orchestration service to run, and other services, other processing units are just in the pool. They can be dynamically added or dynamically deleted. Okay, so all these are used for playing, like dynamically onboarding and offloading. But there are certain set of services wherein standard orchestration service keeps running. And it is the responsibility of this orchestration service to install the AEM instance in the new server or new processor and dynamically run it. And when we are saying the new published instance has to be loaded, it always may not be a new processor. Okay, let's say initially you have these two servers in which the published instance is installed, right? There is one instance of published instance in this server and another instance in this server. Okay, so when load increases, this orchestration service may not always add a new processor. It might install a new instance in the same server. Okay, on the same processor also, it might install multiple instances. Okay, it can, like in the same server, there may be like 4 instances running. So it manages all the CPU cycles and everything. This orchestration service will manage. It knows how many instances of AEM it can run on one server, and based on that, if this is maxing out, the number of instances on this server are maxing out, then it will automatically start a new processor and start installing AEM instances, AEM published instances in this processor. Okay, so that's how this entire concept will work. Okay, so now we understood what is this orchestration, right? But the another thing which we need to know is what is this container. Okay, so we told this AEM application has to be installed on the processor, right? But for the AEM application to be installed, you need to have the AEM application. That is the first prerequisite, right? But to install that AEM instance, you need proper JRE installed, right? Some proper version of the JRE installed. So there are multiple prerequisites, like what is the JRE version, and once you install the AEM published instance, what are certain configurations you have to make to define it as a publisher instance, right? So how do you distinguish otherwise from author instance to published instance? So there are certain configurations which you need to make, right, for it to be established as a published instance. And so all these prerequisites, what you will do it, you will pre-code all these prerequisites and you will put it as part of a container. Okay, so what is the container? Container is that thing which contains the application, its prerequisites like JRE, Java, everything, and also the configurations, everything like a capsule, like a medicine capsule you take, right? You will put everything into that container, right? Like that, all the configurations, all the prerequisite libraries, and even the AEM applications will be wrapped into one container. So that is called as a container. So this could be a Docker container. When you say Docker container, what you are doing in that Docker is you are doing all this configuration. You are putting the application, you are defining the prerequisites, you are defining the configurations, everything you are defining into that Docker container. Okay, so then this orchestration service, which is the container orchestration service. So the example for this could be Kubernetes. Okay, so what does this container orchestration service do? It will take that container and it will initiate that container onto one of the server. So these container configuration will be there in this orchestration service as part of the Kubernetes. Okay, all that configuration, container configuration is defined. Now what it will do, it will create an instance of that container and it will start the AEM application here. So if it is the same processor and if it has to start a new container, then it will be very quick, right? Because you need not find a new processor, you need not install the OS in it, there is no boot up time, right? So automatically all the OS and everything is running already, it is already booted up. You just have to start a new instance of AEM publish in the same server. So that can be taken care by this container orchestration service very quickly. Okay, so that's how it will initiate a new publish instance and it will start redirecting the load. So this Kubernetes also will act as a load balancer. So you have multiple AEM publish instances, right? So this orchestration service will do the load balancing between these multiple publish instances. So that's how it monitors the load, and if this is maxing out, it will start another processor and then again it will boot up the OS, it will provision the server automatically and then it will install the container in it. So since you have capsuled everything into that container, You need not always do the prerequisites, configurations and everything. It is automated. So basically the installation is automated. So that's the advantage of having these containers. Okay, so to give a real-time or real-world example, you can think of the containers like this. Okay, so what we have done here, there are multiple luggages, right, which has to be shipped into a different country, let's say. So everything you have put into a container. So what you are doing by this, you are just standardizing it, right? All this container length and width will be fixed, right? You will just have to fill out your goods into this container. So by that, what you are doing, you are standardizing what is the length, width and height, and what is the weight. It can max weight, it can contain. So once that is standardized, this container you can ship it via road, via train or via ship, right? Any way you can ship it. It doesn't matter. So otherwise, if you just have individual luggages, then you might have to struggle how to ship this, right? So what we are doing in the container is we are just standardizing. We are giving set of rules like how you should, what application you should install, and what are the prerequisites first you should install for that application to run, like JRE and all that other libraries. And once it is installed, what are the configurations you have to do? Everything we are standardizing into Docker, okay, into Docker container, and so that it can be docked or put onto either if you say a ship which might be like a Linux operating system, or it can be transferred via train, which could be like a Windows operating system, right? It can be placed anywhere you want because you have already standardized it. And here whatever you are seeing, right, the things which are putting the containers into the ship, so these are like orchestration. These are doing the orchestration. They are assessing like how much load the ship can carry, how many more containers I can start, right? Each container could be one of the AEM instance, right? All these are one AEM instances which are started, but the ship can carry only so much load, right? You cannot put one more instance, then it will sink into the water, right? So who is managing all that? This someone is who is managing all these cranes, right? Sitting somewhere. They are seeing the load and managing everything, and once this is filled out, then they will send this ship and they will ask another ship to come and they start docking into that ship. So like this you can visualize the containers and container orchestration happening like this. Okay, so having understood all those basics, now let us come to this our AEM cloud architecture. So this is how our architecture looks like. So let's start with content repository service. So here in the bottom you are able to see the content repository services, right? And here you are able to see the author instance. Okay, in cloud what happens is it is not just the publish instance which are getting scaled. Even author instance can get scaled. So as and when the load increases, even author instance will get replicated, or author instances are also containerized basically. So as and when the load is increasing, like maybe you will have to do multiple edits and bulk updates, so many authors are working on it. So then if one author instance is not enough, then it will automatically create another author instance, and it keeps on scaling. So then you might have a doubt, right? If author instances are scaling like that, then how do you replicate the data between one author instance to another author instance, right? Let's say there is only one author instance and 10 people are working on it, and 10 people are making 10 edits. So all those 10 edits are going to one JCR database, right? But if you have another author instance, then do you have another JCR also? Then how do you sync the data between this JCR to that JCR? Okay, so all these conflicts will come, right, if you have to replicate or scale the author instances. So what Adobe team has done is they have deployed this JCR as a serverless technology. So by that what happens is this content repository access would act as a one single point service for all author instances to communicate. So any author instance you take, right, it will always talk to this content repository service only. So each author instance will not have its own JCR. So only author instances are getting replicated, but underlying JCR is one. Okay, so everything will be writing it into only one database. So though your replicating the author instance, will this database be a bottleneck? Right? That is another question we might have. Right? So what happens actually is this is deployed as a serverless technology, which means that this content repository follows these principles. Okay, so the first thing they have done is data shredding, which means that they have divided this JCR into multiple pieces, manageable pieces. Like for example, if you imagine JCR to be like some tables, right? So each table could be placed in one service, let's say, right? So it is not a single database or single instance basically. So each table might be into one microservice. So something like that. They have broken down it into manageable pieces. Okay, so that they can be installed as a containers again into multiple servers. Like for example, what I'm saying is, if you have a table 1, okay, so you have 10 tables stored overall for the JCR, let's say. So then you can break one table into one server. Okay, so then what happens if there is a insertion or retrieval load increasing on one table, then you can automatically replicate or start another instance to handle insertions of the data or retrieval of the data from that table, right? You can create one more instance of that table and you can manage it, right? So now again the problem comes, right? If you are having one table and one instance, that is fine. But for that same table, if you have another instance, then if you have to manage insertion and retrieval, then whether the data will go into table 1 or table 2, or will it go into both? So how that replication happens? So that data replication also will be done. Okay, so whenever you are inserting the data, the content will go into both this instance and that instance. So it will have multiple replications. Okay, the data will be replicated into multiple servers. So if you have just table 1 on one instance, it will not be just on one instance. It might have 10 instances of table 1, and whenever there is an update on table 1, all those 10 instances will get updated and they will be synchronized. Okay, regularly all these tables will be synchronized, and there will be load balancing also. So all these things packed into one service is called as serverless. Okay, so you need not worry how the shredding happens and how the synchronization happens. Everything is pre-configured. Okay, and it is serverless. You need not worry about that. So all we need to worry is like this service. So this content repository service is a service. It's a microservice, and this is the underlying database which contains all this. And this author instance is again a microservice. Okay, this author instance is a microservice. This author instance microservice is talking to this content repository service, which ultimately will insert and retrieve data from this database. Okay, so that is how this is configured. Okay, so then here we see what is called as a published tier. Okay, published instances. Okay, so now if you see, these published instances also can be replicated. So which means that whenever the load increases, the published instances also will get scaled up. Multiple instances can get created. But the difference between the author instance and published instance is each published instance will have its own JCR. Okay, so all the published instance will not share the common JCR. So that's the difference you will have to know from author to publish. Okay, each published instance will have its own JCR. Okay, but for author, though there are multiple author instances, every author instance will talk to the same JCR. Okay, so now if each published instance have its own JCR, then how the content replication happens? So replication happens through replication service. So whenever you publish the content from here, author instance, right, it will automatically replicate this content onto multiple published instances. So each published instance has its own JCR. So this content will get replicated into its own JCR of that particular published instance. So that's how the replication works. But then if you observe, right, there is a difference between the traditional replication service which you have on the on-prem to the cloud. So what is the difference is, in traditional systems, right, for this replication service, we pre-configure what are the published instances, right? But on the cloud, what happens? These are getting dynamically created, and dynamically some of the instances might die down. So you cannot pre-configure the IP addresses or something like that in the replication service. Okay, so what you need to do is you need to maintain a service registry. So all these are internal concepts which Adobe has taken care. Okay, so they maintain something called a service registry. So whenever a new service of the AEM published instance get created, that instance detail will get registered into the service registry, and replication instance will use that service registry to identify to which published instances it has to replicate based on how many instances are there. Okay, so that is what will happen in the author and publish instance. So now if you see that, right, these published instances are wrapped under this blue box which is called as container orchestration service. So I told you, right? So this is the data center and this part is the container orchestration, and all these are individual instances. So this is how they are managed. Okay, so there is a container orchestration service, and this services manages how many published instances I have to run. Okay, and here also you have author, for author also you have container orchestration service. So this orchestration service will observe the load on author instances and published instances, and then it will decide whether it has to span a new published instances or not. Okay, so now if you observe, you are seeing this in the blue color and this in the orange color, right? So what is this orange color? So if you see here, it is per tenant. So to understand this, we will have to add one more layer of complexity. So what is that complexity? Each tenant is one organization. So there could be organization 1 and there could be organization 2. When they are using AEM cloud, there are certain services which are common among these organizations, and there are certain services which are running privately for each organization. Okay, so whatever you see in the orange is the private thing which is running. Okay, and whatever you are seeing in the blue is a shared service. So which means to say that this container orchestration, which is monitoring the load and which is spawning the new published instance, that service is shared among multiple organizations. So this is very important to note. Okay, so then when it is spanning the published instance, then that published instance will be private to that particular organization. So which means to say that if there are two organizations, let's say, so those two organizations will be servers will be monitored by one orchestration service, and if load is increasing on the org1, let's say, then what it does is, and if there is no load on org2, so then what it does is it will downgrade the published instances of the org2 and it will increase the published instances for the org1, so that the load so that the number of servers are managed optimally between these two organizations. Okay, so that's how this shared service of the organization works. So whatever is mentioned in the blue overall here are shared services. Okay, but then this per tenant one is a private service which is running. And even if you see the content repository service is also a shared service, which means that for all the organizations, this content repository service is a single service. Okay, but Adobe has maintained all the security things. It uses the IDs and tenant-based architecture so that it identifies to which database it has to insert. Okay, it will manage all those things using the IDs. Okay, so that is what we will have to trust. Okay, that it is managing everything properly. Okay, but if you see, you can identify what are all the shared service and what are all per tenant services here. So then here you see the content orchestration service. So apart from content orchestration service, there are some edge delivery services also, and here also you see published here and previewed here, right? So what is this edge delivery service? So these edge delivery services are Adobe services which are similar to CDNs. Okay, so these edge services will be all over the world. Okay, so though your server is placed in somewhere in US, let's say, So someone is accessing from India, the website from India. Okay, so even then what happens is you can have this edge service which is placed in India nearby to the client location, and instead of that request coming all over to this orchestration service which is in California, this the edge services only can deliver that data. Okay, you can manage it using the edge delivery also. So this is one more layer of caching all over the world. Basically, it is not just one server. All over the world, these instances will be replicated, so that anywhere from the world, if a person is trying to access the data, you will be able to serve the data from the nearest location. Okay, so then when do you plan to use this edge delivery service, and when do you plan to use orchestration service? Okay, so the one instance which you could think is like, let's say if you are going for the SPA, okay, single page applications, right, wherein the entire application will be run on the client side, and only the static JSON will be delivered from here, right? So in that case, you can replicate all those JSONs onto the edge delivery, so that whenever the API call happens, it happens through edge very quickly. Okay, that API call need not come always to this server where it is hosted somewhere in California or somewhere, right? It need not come here. Since it is just a JSON, it can just get delivered from here. Okay, but if you are doing the client side rendering, like if you are using some HTML scripts and rendering it through the Adobe, right, or through the AEM, so then you will have to obviously come to this container orchestration service. So based on your architecture of AEM, you can decide whether you have to go for the edge delivery or you have to go for the container orchestration service. So all these architectural decisions you can take based on that. And whatever you are seeing in the blue is mentioned as a container, right? Container, we have already discussed what is it. Okay, so whatever is required to start for this publish instance, everything is configured as part of this container. And for this page editor also, what all is required is already configured into a container. Okay, so this is basically a microservice which is running all by itself. Okay, so then how does this publishing happens? Okay, so this is how the publishing from AEM author happens. So it happens to the AEM publish and edge delivery. So when it publishes to edge delivery, then that content will be replicated all over the world. Okay, so sometimes what happens is there might be certain pages on which the load is very high, right? Even though you are rendering, you are using a server-side technology like AEM HTL and rendering it through AEM, the rendering the HTML page through the AEM also, what happens is on one certain pages the load might be too high. So those pages you can deploy it onto the edge services, so that these pages can be deployed from the nearby locations. Okay, and whenever there is an edit on that page, you publish that, and automatically that page will be replicated all over the world also, so that it can be served from the nearby location. And if you see here on the edge services, you can host the images and videos also. So whatever images you are publishing, they also get replicated all over the world into these edge services. So you can configure like that, so that you will have the minimal download time. Always you need not fetch this video from California, right? If you are querying, if you are getting that video from India, so it can be delivered from the nearby location. Okay, so even the preview tier, everything is hosted on the edge delivery services also. So this is the very high level architecture of AEM cloud as service. So I haven't covered multiple things like all these services and everything. The video will become much lengthier, but I have given you the minimum knowledge which you need to know to be able to understand this overall architecture. So if you now read the entire documentation, you'll be able to understand clearly what is each service doing, what are microservices, what are containers, how this publishing, replication and everything is working. You'll be able to get an idea. Okay, so that's it for this video. Jai Hind.